Today we have a 2005 Toyota Corolla with a 1.8 liter engine, and the customer's complaint is that the engine is taking longer than usual to reach operating temperature, and sometimes the needle on the coolant gauge, it drops back down. And so the customer has brought this into me to have a look at it to see if there's any problems. Welcome back to the Moose Mobile Auto Repair channel. And so today, earlier I had a brief look at this Corolla, and I checked to see if there's any trouble codes stored. I found a P0116 pending code stored in the computer for the engine coolant temperature range performance. And so we are going to have a look at this and to see on what's happening. So at the moment, I've ran the vehicle for about half an hour now, idling. It's about 1 degree Celsius here, and so the issue is that the coolant temperature, it was up at about, I think, roughly 175 or 176 Fahrenheit. And so that the vehicle was warmed up earlier, and the coolant temperature gauge was roughly about halfway. And so it was about halfway, almost just under halfway in which it's supposed to be, and then the needle dropped onto where it is now. And so at the moment, this vehicle has a pending code for the P0116 range performance code for the coolant temperature sensor. So I still have to test the sensor to see if it's okay. Now, I've recently already replaced the water pump and the thermostat and housing on this vehicle not too long ago. So I don't think it's a thermostat issue. And the other problem is that I had a look under the hood while the engine is still cold and not maintaining the proper temperature. I noticed that the radiator fan is coming on and off, and it's not supposed to until it's reached operating temperature. And usually when it's at operating temperature, that would signify that the thermostat has fully opened. And so when the thermostat has fully opened, and then the radiator fan should be cycling on and off for as long as it needs to. But even when it's cold, the radiator fan is still cycling. So that's going to cause the engine temperature to drop by a considerable amount and use more fuel. And so it's going to switch back and forth to closed loop and open loop, and that's not good. So right now the engine is in closed loop, so it will be utilizing the data from the oxygen and air fuel sensors. But usually this is not good if the engine is always cold or stays cold, because then it's going to keep on switching back from open loop and closed loop. And so that's not good, because when it goes to open loop, the engine computer is going to be relying on the engine coolant temperature sensor. So this will tell the computer to either to enrich the fuel mixture for cold weather drivability, or to reduce the fuel mixture, depending on the driving conditions of the vehicle. So right now it's in closed loop, but sometimes it switches back and forth. So I printed out some information from service information or service data. It's a P0116 engine coolant temperature circuit range performance problem. You just have to be careful here. This is just take note that this is a range performance problem. So you need to watch out. Most likely, when you get a range or performance problem, usually it's not typically an electrical issue, although it's still possible. It's more likely sometimes a sensor issue or an other underlying problem in the circuit, or something else that's causing the computer to trip these codes for a range performance issue. So I'm just going to go over this briefly. So it said case 1, engine coolant temperature ECT between 35 Celsius and 60 Celsius, 95 and 140 Fahrenheit when engine started. Conditions A and B met. 2 trip detection logic. Vehicle driven at varying speeds, accelerated and decelerated. ECT said conditions B, A, B. So I'm just going to go over this briefly. These are the conditions in which it trips this trouble code. The trouble areas ECT sensor. So it said monitor description and strategy. It just explains to you on how the computer detects and trip this code. I'm not going to go over this completely in the video because it's going to be too boring for you guys. So this is just some information that I found to see on how the system works. And it's saying here, if you have other codes, it's saying to diagnose those codes first. But we only have one code for P0116. Then just the resistance values. So now we are going to get started with the diagnosis, and I'll guide you through the process. So now I have the multimeter connected to the engine coolant temperature sensor. You can see the numbers jumping around a little bit. 2.17 kilo ohms. So that's 2,170 ohms. So we are going to compare that to the specifications. The engine is cold at the moment. So I'm having a look at the specification for the 1ZZ FE or 1ZZ FE if you live in the USA. Pronunciation is different because I live in Canada. So if you look here, engine coolant temperature sensor resistance 2.32 to 2.59 kilo ohms at 20 Celsius or 68 Fahrenheit. Right now it's 11.1 Celsius in the garage over here, 52 Fahrenheit. And I'm getting 2.2 kilo ohms. So I'd say it's relatively pretty close for the temperature range. Now this sensor is a type of NTC sensor, a negative temperature coefficient. So that would mean that when the engine is cold, the resistance is high. And when the engine is hot, the resistance is low. So it's opposite of what the readings are for the resistance checks. So I know that this issue is intermittent. It's not fully there, but because it tripped the P0116 code, it's saying that there's a problem with either the sensor or something else. But I believe that the sensor is most likely the issue on this. So the engine coolant temperature sensor, it's located in the back over here. I just removed the PCV hose out of the way so I can get some better access. It's inside the cylinder head over here. And then you see the connector. It's a 2-pin connector. So it was a bit hard to take off. I just used my thumb. When you put it in, it's connected at the bottom, so you can't see the tab. So I use my thumb at the bottom, and at the same time I use a flathead screwdriver to pry at the same time as you are pushing down on the connector. You will need a pretty strong thumb to get it out, unless you remove other stuff like the air box to get better access and use like some pliers or something. Otherwise you can do it this way. So I took the connector out. It's a 2-pin connector. Just to make sure you inspect for any corrosion or any damaging to the wiring first. Make sure everything is good. And then you can proceed to check for powers and grounds on this one. Now, you may not be able to check some stuff directly here, like for the 5-volt reference a signal that's controlled by the ECM. So you might not be able to test that in some circumstances, but we are just going to do our quick checks just to make sure the electrical is okay. So I turned the ignition on, and the moment I turned the ignition on, right away I noticed that the cooling fan is running the entire time. So what we are gonna do is we are just going to connect a test light. We'll connect here to the negative side to check for power on one of the terminals. You check one of the terminals to check for power. So because now I connected the test light, when I insert it, the cooling fan is going to turn off because the computer thinks it's receiving a signal. Because now this is like the computer is sending a signal to the connector. Because right now the cooling fan is running on full speed all the time, because it's not receiving a signal from the engine coolant temperature sensor. And so because it's not receiving a signal, the computer does not know if the car or the engine is overheating or not. So to be on the safe side, it commands it to turn the radiator fan on, and it will remain on until it starts to receive a signal. So when I insert this into the terminal, the cooling fan will turn off. So I'm going to insert this here. And now, as you can see, the cooling fan turned off now, because when I check on the when I check on the test light, I should be getting some voltage. So that's for that. So again, I'm going to show you. I inserted a test light into the pin here, and now the cooling fan turned off. I'm not getting anything on the LCD or the LED display here. I let go, the cooling fan turns on. So I believe that the 5-volt reference power is right here because the cooling fan is turning off. So I know that the wiring is okay on this part. So now I'm going to switch over to the positive side to check for ground. So I'm going to check for ground, and you can see right here, you're getting voltage here. 11.8 volts. I don't know if you can see that. 11.8. There's nothing here because I'm connected onto the positive side. It's opposite. I'm connected to the positive side of the battery. So this is to check the ground side of the circuit. So right now I'm going to do the exact same thing just to make sure. I'm going to be using an incandescent test light just to be on the safe side. I want to make sure that that my diagnosis is 100% because I don't want to throw parts at it. So I want to make sure that everything is okay because there are some times that some test lights can give you a false diagnosis. So I like to double check things just to make sure. So we're going to do the same. I'm just using a regular test light over here. I'm not getting anything on the regular incandescent test light when I connect it to the negative. Now I'm going to connect it to the positive. I'm getting ground here. Ground that we checked earlier, in which you saw on the other test light, it was green. So you're getting a good ground. For some strange reason, this other test light that I have is a Mac Tools test light. Now this test light that I have here is a Mac Tools test light. It does 3 to 49 volts to check for circuits. For some reason, I believe that this test light is a special one. I think this acts like, sometimes it acts like a reference signal for those small circuits that don't produce that much voltage because it's not doing the same with the regular incandescent standard test light bulb that's in here. So I'm going to hook up the Mac Tools test light, insert it to where there's should be the 5-volt reference. The cooling fan turns off because it thinks that there's a signal now, so it shuts the cooling fan off, which is strange. Which is strange for this one because the standard test light it doesn't do it. So I'm going to do the same for the power probe that I have over here. This piece here is a 5-volt reference probe to check for those 5-volt reference circuits. So I'm going to hook this up. So for the sake of safety, I'm not a big fan of these power probes by activating power in ground because sometimes you could damage the computer, the ECM or the PCM. So I don't like using this. I just want to be on the safe side, even though I have the 5-volt reference probe here to check for 5-volt circuits. So I go over here and you can see 4.4 volts, and over here is ground. Also, if you take note, it didn't turn off the cooling fan for some reason. So again, 4.5, 4.4 for power, the 5-volt reference, and this is ground. So as you saw here, all of the electrical checks out okay. I didn't find any problems or issues. It's most likely an intermittent problem with the sensor itself, because it tripped a pending code for P0116, and so the check engine light did not come on yet. And in most cases, the check engine light does not come on for these types of codes for the most part. Now, as you can see here, all of the electrical testing tested out to be okay, and we didn't find any problems. And so, although the check engine light is not on at the moment, it did store a pending code. So this is a 2-trip logic detection code, and so it would need, this issue would need to happen 2 times or 2 separate drive cycles until it trips the check engine light. And so because it's somewhat of an intermittent problem, I didn't find any issues in the electrical, but it's most likely that there's an issue with the sensor itself. And so we are probably going to change out the sensor at this time and put it in, because there's no other checks that I can do. No, I've already done testing on it and checked the resistance of the sensor. I couldn't find any problems with it. Most likely than not, it's intermittent. And so because the computer did not see that the engine warmed up to specific parameters in which is programmed into the computer, and so because it didn't see those parameters, it tripped a pending code saying that there could be a problem. And so if this issue happens again, it will trip the check engine light. Now, in some cases, when you have a pending code but the check engine light does not come on, it's not usually a big problem, but there are times that when you get a pending code that the problem is going to show up soon. Now, this circuit tester that I have is a Mac Tools ET28830 is the part number. I don't think they have it available anymore. I got this years ago. I believe it's a special type of test light, because it checks for the 5-volt reference to see if it's working or not, and it's saying that it's computer safe and it will not damage sensitive electrical components. So it's safe to use this. So it will not damage anything. And there's some sophisticated electronics inside here. So this is designed in such a way that you can do your testing and not damage anything. And then now we have the regular incandescent test light bulb, which is the standard test light. Sometimes using this alone is not enough. So sometimes you will not be able to see any problems in the circuit. So you have to use multiple test lights and tools, because this test light usually works for circuits that that require a lot of voltage and amperage or a current. And so because there's a regular bulb, it takes more voltage and current to light up this bulb. So for most larger circuits, this test light is good to use because you need to produce more energy in the electrical system to light up this bulb. So that's why I use this incandescent bulb instead of the LED bulbs, because the LED bulbs don't require that much power to light up. And so there are some circuits that it may be partially working and it will still light up those LED lights or bulbs. And so it will give you a misdiagnosis. So you will misdiagnose the issue by using an LED test light. So you need to be careful. So that's why I like to use 2 or 3 different test lights just to make sure that I'm testing the circuit properly and I know on how much voltage there is or current and on whatever I'm looking for. Because I want to be on the safe side of things and I don't want to misdiagnose the circuit, I use the incandescent test light in this Mac Tools test light that tells you the voltage as well on the screen. And I also use the power probe as well. And then there's the separate adapter over here to test for 5-volt reference circuits. Now, if you notice, when I have the ECT, engine coolant temperature sensor, unplugged, I put the ignition to on, but engine off. The engine is stone cold right now, and you can see the needle is about halfway or just slightly less than halfway. And so when I'm just using my phone to check for codes for the sake of time, and you don't see the pending code anymore for the P0116, you see P0118 now for engine coolant temperature sensor 1, circuit high. That's because I was doing some testing earlier, and so I have the connector unplugged. So I believe that this computer vehicle would go to like a fail safe mode. Basically, if the sensor were to stop working, it would go to like a fail safe mode, and it would just basically say that the engine is warmed up, and it would turn the radiator fan, and it would stay on the entire time because the computer doesn't know on what the temperature is. Now I just wanted to let you guys know that I have a lot of history on this vehicle, and no, it's not a thermostat problem, and the thermostat has already been replaced recently, maybe a year or 2 ago. So I've already replaced the thermostat with the OEM Toyota thermostat. So it's not that. Although it's possible that a thermostat could cause this problem, but uh, it would trip a different code if it was a thermostat, and most likely than not, it's a engine coolant temperature a sensor problem. It's a sensor issue on this one in a majority of cases, but you still have to do your diagnostics to verify and just to make sure. So now we're going to be replacing the sensor now. So we are just going to remove the radiator pressure cap just to relieve any pressure in the system, if there's any. So we just leave this here loose, We're going to proceed to remove the sensor now. So before you do this, make sure you have a drain pan underneath the vehicle to catch any coolant. It's going to make a mess because there will be some coolant inside the block. So I remove the plastic protective clip for the fuel line hose, the safety clip. So I remove this out of the way to give me some room. Now I'm using a 19 millimeter wrench. So I'm using a 19 millimeter wrench. So I remove the PCV hose out of the way. So I put this, in order to get this on, you have to put it on a specific way if you're using a standard wrench. Unless if you have a special type of socket, like the sending unit sockets, like for the oil pressure switches and knock sensors and things like that. There are some specialty sockets. I do have some, but I can't find them at the moment for this particular size. So I'm just using a wrench. So I placed the wrench in between the harness here beside the fuel line area, so I can get it onto the hex on where it's seated. So I'm going to loosen up the sensor now. I'm gonna be careful. Once you loosen it up, you can just loosen it up by hand afterwards. That noise was just from the plastic, the wire loom stuff. There's not much working room here. So I'm going to see if I can loosen this up by hand or not. And you're just going to have to continue to loosen it up. So take note that this sensor is not on very tight. So when you get the new sensor on, you don't need to tighten it up that much. I will see if I can find the torque specs to see if it's available. So now I can remove this by hand. My arm is in the way, unfortunately, but it's down here. So we can see that I'm removing it out of the way, and coolant will be coming out if it's above the level in the block or not. So it depends how much coolant there is inside. It's going to make a big mess. So now you can see the coolant is draining out. Make sure you adjust your drain pan accordingly so that you're able to catch the coolant. And later we are just going to wash everything down with water afterwards. So this is the old sensor. So now the coolant is just still draining a bit from the block. You can see down there. So here's the new sensor. It comes with the Teflon tape that's already there, so you don't need to add any kind of sealant. There's the washer as well. On the old one, it has a copper washer. It has a copper washer. So make sure that copper washer comes off when you remove this sensor and it's not stuck onto the block and or the cylinder head. I'm using an aftermarket part, BWD. These usually work okay for me in a majority of cases. I haven't had too many problems with these parts, but most of the time they work okay. I can't always get the OEM stuff because of usually because time and availability hours and stuff, and the dealership is usually closed in some cases, so I'm not able to get the OEM parts. But if you can, it's best to get the original parts if you're able to. So we are just going to do resistance checks again, just compare both of them side to side, just for reference. This is 2.9 kilo ohms for the old one, about 2900 ohms, 2.9 kilo ohms. Now this one is 2.7 kilo, 2700 kilo ohms. So the numbers are a little lower on the new one and constantly changing. You can see the numbers are dropping quickly. 2.643 going down. Let's have a look at the other one again. 2.7. It's very similar to the new sensor, but this one is intermittent, so you may not be able to see problems with the sensor. We're going based on our test, and because that there was a pending code, so we are replacing it. So these sensors are pretty much alike. So we are going to install a new sensor now. So at this moment, we are going to thread in the new sensor by hand. Take note of the washer here. Make sure you don't lose the washer. So we are going to install the sensor by hand. Make sure that there's no dirt or anything in the way. If you want, you can just do a quick wipe. Make sure there's no dirt. And wipe it down if you need to. And you can reinstall the sensor. I don't think you need to lubricate it or anything. You should be fine. So I'm going to thread this in by hand all the way. And then we are going to tighten it up using the wrench afterwards. Just trying to get it in straight so we'll be able to catch onto the threads. Now, in case that if you are having a hard time, you can use either a 20 or 21 millimeter socket just to thread it in by hand, because the 19 millimeter is a bit too tight to make it fit over the sensor. So usually you can use a 20 millimeter and tighten it up by hand if you want. You can even use a ratchet and the socket too to tighten it up all the way by hand. And then later you can just use the wrench to snug it up a tiny bit using a wrench after it's tightened up all the way by hand. So once you turn it all the way by hand, eventually it will stop spinning. And once it stops spinning, that means it has touched the block. So after that, you can just use a 20 millimeter deep socket, half drive and a half drive ratchet. Just give it a little bit of some oomph, and then you should be okay. Just tighten it up a tiny bit, and then you're good. You don't need to tighten it up that much. And that's it. Once you tighten it up, and then you're all good to go. You just need to reconnect the electrical connector, and then just put everything back, wash the coolant down, and you should be all good. So if you look closely, you can see that the gold yellow portion, it has touched the block. So once it touches the block, you just need to tighten it a tiny bit. And if you notice, the tab connector is facing upwards this time. Originally, the connector was facing downwards. That's not going to matter, but that will make it easier for future repairs if you need to disconnect the connector, because now you're able to see it from on top, whereas originally it was facing downwards, so you can't see in where the tab is. So now all you need to do is reconnect the connector now. It should click in place after it's in all the way. So it should click. Just make sure it's firmly in place. Verify by tugging onto the connector back and forth, just to make sure it's clipped in properly. And we're going to put everything back now. So reinstall the fuel line clip facing downwards, and then we're gonna reinstall the PCV hose. Reinstall the PCV hose back. Adjust the clamp. And later we need to reinstall the engine cover and everything. And we're going to wash down the coolant and bleed the cooling system afterwards. So once you're all done, before you start the engine, we're gonna wash everything down. Make sure the dipstick tube for the automatic transmission, if you have an automatic transmission, is inserted all the way so water doesn't get inside there. And then later we are going to fill it up with coolant. So just going to wash down all the spilled coolant that came out of the block. It's perfectly safe to use water. It will not do any harm as long as the water and the engine are at the same temperature. So the engine is cold, so I used cold water, so it won't cause any problems. And then it will just air dry on its own. Just make sure that all the coolant has been cleaned out. And then later, after I run the vehicle and stuff, we are going to double check for leaks. Make sure there's no leaks. Then we are going to bleed the coolant. So we're going to be using the Toyota Super Long Life coolant, the pink stuff. We're going to fill it up. Not too much coolant drained out, so you probably don't need that much coolant if you're just draining from the block on where the sensor is. But you will need to bleed the cooling system manually all over again. Usually anytime that you have worked on the cooling system, you will need to bleed it. I have a video already on that when I did the water pump on this vehicle, so I will post the link in the description and also on the screen if you guys want to know on how to bleed the cooling system. So now just clear the codes, and after you clear the codes you can start the vehicle. And now I'm just bleeding the cooling system, verify for leaks, make sure there's no leaks, and then you should be all good to go. And then after you're all finished, go for a road test, and then come back, verify for leaks again, and then that's it. That's it for today. If you enjoyed this video and found it helpful, please don't forget to give it a like, and please consider subscribing to my channel if you're not already a subscriber, and I'll see you guys in the next one. Have a good day and take care.